you have a, when you write something, that is your single record, right?
Yes.
Now you have to logically group these records,
Mm-hmm.
and that logical grouping is called table.
Yes.
And now you have x number of tables, and
Yes.
the grouping of these x number of table make the key space.
Okay.
Now let me actually rephrase that. Let's say I own that computer, and you comes to me that, hey, I want to use the database here, right?
Mm-hmm.
So what I do, I create a namespace for your business name, and now say that, okay, you put your data inside this. This is logical. It's not physical. It's a logical thing,
Mm-hmm.
right? So that I can easily figure out that how many number of total number of rows you have. I can just go and fetch from your key space.
Mm-hmm.
How many
Yeah.
tables you have, I can fetch from your key space.
Right.
Same way, the other person comes and demand that, hey, I want to store the data. I create a separate key space for them, so that the data should not get mixed. But it's a multi-tenant system, so the data here, tenant, you can say that different user, but in your case could be two different kind of application, two different kind of business belongs to the same company. So does it make sense, that key space now?
Yeah. Yeah. But it
Okay.
is saying on like, yeah, you gave example of one machine.
Yes. Yes. Now let's move forward. If it's clear now, let's talk about that. Why do we need the replication? What is exactly replication? And why do we need that? We need the replication for durability, right?
Yes.
If one system get, if that hard disk of that system is in bad shape, we lost our data. So we need to keep the data at somewhere else too,
Yeah.
and that's why we
Different
call,
data center. Okay. Yeah. Like that.
yeah, forget about data center, just the second system, second drive,
Hmm. Okay.
right? So we keep, so when we say that replica, so it's a, and we are just talking about that the plain mirror copy, exact whatever we have on that host, we move exact, make the exact copy, and that's why we call the mirror copy. So we keep that on the second system. Now when it, the author says that three replicas, that's it, means you have exact three copies. If it says that five-way mirroring or five copies, exact five copies.
5 copy of me, right? So it will be total 6.
No, including that, everything.
Okay.
It's not one is that on the host. If I say that three copies, so three different hosts will have the same data.
Mm-hmm.
So now when initially we started that the key space on single host, and now when I say that, okay, you come to me and I own that to host, and I you say that, okay, I want to store the data, so I will create this logical key space, and that is actually spent around these two physical hosts. Though it's a logical, but the data from those, that key space actually persist, I persist on these two physical hosts. And
Okay. So
the group
maybe
of these two, sorry.
yeah. So no, in that case, maybe in the key space they might be putting the host ID too, so that it is going to the other, which data should go to the other host, right?
Oh, that's a different story.
Yeah.
Right now, just think about that. Magically, something, there is some black box which will tell you that where the data will go,
Yeah. Yeah. Mm.
right? So the group of these physical nodes we call cluster. So if there are n number of physical hosts, so when author is talking about that, okay, it's a cluster of Cassandra nodes. So that means n number of the physical computer, and those are part of the same cluster. They are working together.
Yeah, I mean, there is two clusters in, but key space can span from one cluster, one node, to second cluster, one node.
No, 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 no.
No.
Within here, let's say here it shows that four nodes, four physical nodes, server one, two, three, four, right?
Mm-hmm.
They are they are combined together, make a single cluster,
Okay.
right? So the cluster holds these four physical server, and these physical server, we may have n number of key space into that. But the replication factor, so now you come to me and you say that, okay, create my namespace and my data is very crucial. I want the replication factor 3, right? And someone comes to me that and say that, okay, I want the replication factor only 2 because my data is not critical, or I don't have the money to pay you to make the 3 copies. Because ultimately, everything is actually bound to the money. So if I need the three replicas, I will have to pay more. So that's why author was saying that
Mm-hmm.
you can the configuration what you have to set, that configuration is for a key space. So you set the replication factor. Say like within same cluster, you may have n number of key space, and each key space has its own replication factor.
So suppose in the above, like, yeah, we'll go to the above picture only. So in the above picture, server one, server two, server three, server four, we have. So so in that, I have a table. I have like server one will have 5 key space. Okay. Now that 5 key space, I want one key space which has to be on the server four and server one. So that can also happen, right?
Sorry, could you repeat again, please?
So on server 4, suppose I have 3 key space on the same machine. Okay.
Mm-hmm.
One more key space I want, where I want put put my data on server 1, some data on server 1, and put some data on server 4 because of some reason, I don't know. So that we can do or not in the key space.
So you can, within a cluster, you can ask the your that I want to create a new key space, which you can, but you cannot actually decide where it will, which node will hold that key space data
Now, I want
within
to
the
hold
cluster.
on the two nodes,
So
like server 1,
Yes,
server 2.
just
because the
Praveen,
system, or the control plane will decide that it will balance the data and decide that which node actually has the capacity right now, and it will place that key space on that node.
uh,
Okay.
Praveen,
Yeah.
sorry to interrupt you here. So is it safe to say this, like, we are talking in terms of key space because one key space will be distributed across, or will be managed by one consistent hashing ring. So everything that we are doing is keeping the consistent hashing ring or the key space as a central component, and then based on that we will come up with the partitions, and based on that we will be distributing them in a virtual nodes or nodes, because that's what we do in a consistent hashing ring, right? Is this a good
I mean,
to put it?
right now you can say so. Could you repeat again? I mean, how you are actually connecting that the key space with the consistent hashing? How you are thinking?
Yeah, so what like, if we look at this particular diagram here,
Uh huh.
our, let's say we have 1 to 100 keys, let's say, or 1
Right.
to 100 records,
Mm-hmm.
1 to 100 primary keys, I'm choosing to call it. So and my key space has 100 records, that means I will have 100 primary keys. correct? 100 unique records, that means 100 primary keys. So
Mhm.
now my distribution, like everything needs to be partitioned, right? With the partition key and with the clustering key and stuff. So I can just put all these 100 records over a consistent hashing ring. And then let's say if I have 4 nodes, then my consistent hashing algorithm will come up with distributing the keys amongst 4. If one of the node goes down or a new node is added, then it will take care of getting it distributed among 5 or likewise. So and based on that, the data will be distributed in actual cluster. On top of that, we will add some mechanism which will also take care of replication, so it will be distributed multiple times in like over the node, so that like multiple times over these 4 nodes, so that we will have copies residing in other nodes too. So I'm looking at in this analogy, does this matches with what you're trying to say, like? Or
Yeah, I mean, you can say that. Okay, so we are actually linking that key space with consistent hashing. The consistent hashing has nothing to do with the key space. Key space is, as I said, that is just a logical thing,
okay, understood.
right? Yeah. So now within your key space, whatever number of keys you have, right?
Mhm.
So those will be um, uh, distributed to. So I mean, the author is trying to actually take you up to that point slowly.
Mhm.
So it's not that simple, straightforward. So the key space when you provision your key space, right? So the control plane will decide that based on your uh, input, right? How big your you, your key space will be. I mean that, okay, you said that, okay, my data size will be X, and uh, I need the read throughput
Yeah.
Y, and I need the write throughput Z. Based on that, it will decide that how big should be the cluster, how big should be the key space, how many number of nodes you will require. And then it actually get those number of node and assign to your key space. And
So,
now
yeah, go ahead.
and now when you actually write something, let's say, so now based on that, because let's say for your key space it decided that you need 4 physical hosts, so it will actually, now it will use this hashing to redirect to now it has this the key range. Let's say your key range is from 1 to 1000, what you are saying, that's and now based on that it say that, okay, key range from 1 to 250, the primary node for that range is server 1, 251 to 500 server 2, 501 to 750 server 3, and rest of them to the server 4. And now let's say a write arrives, and as you guys were discussing about the coordinator node. So let's say the write arrives, and write is for key 1, and somehow it landed on server 3. Now server 3 know that, oh, I'm not responsible for key range 1 to 251. I'm only responsible for 501 to 750. But magically it figured out that server 1 is responsible for that. So that server 3 redirect that request to server 1. Server 1 know that, oh, this is for me. It write that, and based on the configuration of your key space, what is the replication factor, then uh, uh, server 3 at the same time it will determine what is the replication factor and what are the replicas host. It will, let's say for replica, it's server 4 and server 2, then it will also redirect that write to 4 and 2. Make sense?
Yeah, very much clear. So, from your whatever you explain, I just got this in my head that so in this diagram where four nodes are there, server 1 to 4, one table is spanned across these four servers, right?
Mm-hmm.
Yeah, and it is part of one key space which is also spanned across these four nodes in a cluster.
I
One
think
table is
to be
across.
honest, I think sorry. To my knowledge, so far we haven't yet talked about the table at all, right? Just correct me if I'm wrong.
Mm, I'm considering this whatever data is being shown, state, city, zip, is as a part of a table, and this is how it is distributed across multiple nodes. So that table is spanning multiple nodes in a cluster in a key space.
Yeah, yeah. Ignoring this diagram per se,
Hmm.
I think whatever Praveen was discussing, to my understanding, we were talking about the key space distribution or key space only,
Yeah,
right? And
key
then
Yeah,
space
key
going
can
by
space.
be
Yes.
the
across multiple nodes.
yeah, so with that,
And
it could have
Mhm.
one table, it could have multiple tables, like
Yeah, it can have multiple tables. What I'm saying is, this particular example, if you see the way it is distributed over these four nodes, it appears that this table is spanned across. There can be multiple tables also, but this table data is spanned across multiple nodes. And plus, there will be replication of this each data range as well.
No, I think this table you are understanding as a table, but it is just a representation. It's not a real.
Yeah,
Yeah.
logical representation of the data.
Yeah.
Maybe you can consider a table, or but it is a logical grouping which
Mm.
is spanned across four servers in a cluster. Okay, shall we go ahead?
any other questions, anyone? Like, I think it's a good discussion. I think before we go forward, let's make sure like we have internalize all of it. Okay, okay, we may continue.
Replication strategy: the node that owns the range in which the hash of the partition key falls will be the first replica. All additional replicas are placed on the consecutive nodes. Cassandra places the subsequent replicas on each node in a clockwise manner. There are two replication strategies in Cassandra. Simple replication strategy: this strategy is used only for single data center cluster. Under this strategy, Cassandra places the first replica on a node determined by the partitioner and subsequent replicas on the next node in clockwise manner. Can you scroll up? Just a diagram explaining how it does it. Scroll up.
So what we are doing right now, what we are discussing right now, is nothing but a typical consistent hashing mechanism, um, like for the distribution of key space and like stuff that we were discussing so far. Like,
So
this is the
here
consistent hashing part of it.
replication factor equal to 3 it's showing. Server like these three will have data, right?
Yeah, the replication factor is equals to like number of nodes we are writing a particular row.
Yeah. It should show only three, right? Like from two, as per previous things. The coordinator client is coming on the server, the left one, and then one more is there, and then the other is there, right? I mean, currently it is saying replication factor three, but four
No,
nodes are
it's
in there.
not four.
No, no, no.
So
So
coordinator is node is not responsible for writing or reading the data. So it is
Oh,
just
okay, okay. It
passing
is
through the state.
forwarding.
Yeah, yeah.
Okay.
It is just coordinating.
Oh, got it. Yeah.
Anyone else wants to read?
Yeah, I can read. Network topology strategy. This strategy is used for multiple data centers. Under this strategy, we can specify different replication factors for different data centers. This enables us to specify how many replicas will be placed in each data center. Additionally, replicas are always placed on the next node in clockwise manner. So here we have a freedom to choose which data center and how many number of replicas. Can you scroll down?
Just a minute, analyzing this, what it is saying. Does it talk about? Okay, each cluster has a different replication factor. So here, so the coordinator itself is responsible for forwarding it to the remote coordinator. Okay. So when it says clockwise, server, this server, the first coordinator server will send it to this server first, right? And then to this, and then to this. Is that correct?
Right.
Okay.
So anything the very next in a clockwise direction and the next to it.
So I think after this server one, the next request is for remote coordinator.
Mm,
I
should
mean,
be.
that is how it is shown, but yeah, let's go ahead.
What are Cassandra's consistency level? Cassandra's consistency level is defined as the minimum number of Cassandra nodes that must fulfill a read or write operation before the operation can be considered successful. Cassandra allows us to specify different consistency levels for read and write operation. Also, Cassandra has tunable consistency, that is, we can increase or decrease the consistency levels for each request. There is always a trade off between consistency and performance. A higher consistency level means that more nodes need to respond to read or write query, giving the user more assurance that the values present on each replica are the same. Do we want to discuss that?
Yes.
so basically, whenever a read request, so does anyone need any explanation for this, or like I?
I think it's basically the acknowledgement, right? It won't consider it as successful unless you get an acknowledgement, like what we read previously.
So acknowledgement or the commit could be for write operation, correct?
Right.
But even during read, like the consistency consideration come during the read request. So whenever we are reading the data, it won't be read from just one single node where the request has landed. It will be read from all the replicas or all the copies. It will tally the record, it will tally the value that has came up from all the copies, and uh, based on that, like it will try to find what's the correct record. So there could be a node, let's say our replication factor is 4. I'm like deliberately taking it 4, the reason being, so let's say three of the nodes shows some particular value, and fourth node could show a stale value, because there is a possibility that it might not be updated. There is a possibility that the record didn't get copied properly on the fourth node. So if three records are pointing to some value and fourth record is pointing to the other value, it will the fourth record fourth node value will be discarded, and whatever the consensus has been built, that value will be returned as a row read, as a row is getting read. Does that helps? Like, slightly confusing, but basically there is a consensus that is being built for every single read request, and we need to serve the most latest data. There could be a stale data, and here the most latest data is being served, and there is something called as quorum. That quorum is nothing but the consensus, or like quorum is basically the source of truth, the record of source of truth, that's what they say, or system of record. um, where like whatever information that forms a quorum has to be a source of truth. uh, so when the quorum requirement is met, it will just serve the read request with whatever the latest record comes in.
So it'll affect the performance,
Correct.
and it'll
Uh,
depend on the system, right? How if you need that much of um, like um, like it'll depend from system to system, right? If you need to check on the copies or not, like
yeah, correct. So yeah, so you are correct in actually pointing out basically the whether there is a requirement of so much deliverance or due diligence or not, which basically nothing but the consistency level that we set. There could be weak consistency, there could be strong consistency. Based on the application we will set the consistency level, and that's why they are calling it tunable consistency.
So,
So the strong consistency levels will definitely affect the performance. So that's a trade-off that we need to consider here.
Sagar, here this highlighted line, Cassandra allows us to specify different consistency level for read and write operations. So read can have a different consistency and write can have a different consistency level. That is one thing. And Cassandra has a tunable consistency. That is, we can increase or decrease the consistency level for each request. How anyway, is there a further discussion on this down the document?
So to me, I think my knowledge is limited in terms of the tunable consistency per request. I am
Yeah, each
basically I'm aware
request is
that,
what's putting me into puzzle
yeah.
for each.
I think tunable they mean like read and write would have different consistency, because usually write is you don't need higher level of consistency for a write request because it gets written to one and then copied on to
No,
the others. It in
Actually,
con-
what
in
I'm
con-
thinking is read anyway, read and write. It is saying that you can have a different consistency level. When it says with request, probably we can send the consistency level,
Mhm.
which can increase or decrease the consistency for each request. Otherwise, how it is possible? How node can make a decision or the Cassandra can make a decision for this type of request? This should be the consistency level.
yeah, the first point, the previous point, I'm pretty much clear that the different consistency levels are required for read
Hmm.
and write operations. Asim, on your point, basically, even in read, we need to have a high consistency in case if you want to have a like for a consistent records, write consistency is very important. Whereas the read consistency will tell us about whether it is eventually consistent or whether it is strongly consistent. Whatever read is happening, there could be a stale data read, or there could be the latest data read. That's read consistency. But To be able
sense.
to avoid data corruption, we need to have high write consistency. Let's say if we want data accuracy is our priority, then we need a high write consistency, because let's say if we set a requirement of 3 copies to be written before we can commit a write, and let's say two of them got written properly and third one is a fail, or acknowledgement is not yet received, so the quorum will be set for like majority of the right. That means out of three, two, even two rights succeed, then it can go ahead for committing. But there is a possibility that one of the two nodes which have accepted the right operation might not respond during the read. So there basically there could be possibly scenarios which could lead to the data corruption if we set right consistency level to be weaker, on a weaker side. So that's about the write. For the read, it will tell us whether it will be eventually consistent, or whether it is strongly consistent whenever the read operation is being made. So eventually consistent means we won't be able to read the latest data but right now, but we might be able to read it after some time, after some basically some hours or days, when the when the read copies have synced up with other nodes or other copies. So that way we can say that it's eventually consistent. It might not be consistent in the same moment, but it will eventually be consistent. So that's about the read consistency. Does that explains your doubt? Yeah. Anyone away? Praveen, do you have any uh, like uh, details about like the tunable consistency per request? Like,
I mean, not from Cassandra point of view, but tunable is, I mean, like you can change per request as you already explained that you can change that um, if it's required. So the most of the time I have seen the quorum base, but yes, if your system is your use case is like that, you want the read as fast as possible, but you are okay as write are very slow, and you are okay to take some latency hit on the right side. So maybe you can configure say like write all and read one.
So
So
I just searched on the net. I see that yes, Apache Cassandra's tunable consistency allows user to set the consistency level for each request, including reads and writes.
oh, okay. User, you mean?
Yeah, so user
Each
to
request means what? Like, suppose you
when you make a do some communication, say like you send some write or send some read.
so if yeah, so if you are sending some right, like some post you are making, in that post you will write something like I want the consistency for this one to be something.
Yeah, you will pass the parameter that what kind of consistency you want that for this
Mm,
particular request.
This says the client application consistency refers to how up to date and synchronized a row of the Cassandra data is on all of its replicas. Cassandra extends the concept of eventual consistency by offering tunable consistency for any given read or write operation. The client application decides how consistent the request data should be. So, probably sending it as a parameter in request. Okay.
Would you be able to share that in a group? In the group?
Uh, yeah. I just did a Google search on the first page itself.
Oh,
All
okay.
that information is there, so I put that.
Okay, okay.
I gitbook.io, gitbook.io. Let me see. Yeah, I found the page. I have posted it in our chat.
Thanks.
Okay, let me go back to the screen that
Can
I'm
we read
sharing.
whenever? Can we read that paragraph again? Maybe.
Are you guys able to see the screen?
Yeah.
Yeah, okay.
Cassandra's consistency level is defined as the minimum number of Cassandra nodes that must fulfill a read or write operation before the operation can be considered successful. Cassandra allows us to specify different consistency levels for read and write operation. Also, Cassandra has a tunable consistency, that is, we can increase or decrease the consistency level for each request. There is always a trade off between consistency and performance. A higher consistency level means the more nodes need to respond to a write or read query, giving the user more assurance that the value present on each replica are the same.
The same
For
thing I think
perform-
Sagar said just now.
yeah, performance in what numbers they have not given, right? Like how many, how,
So as Praveen mentioned, it would be in terms of latency. Uh, like
yeah. So
latency
the
of
numbers, yeah, I mean, 200 millisecond, 20 millisecond. What in general? What is for Cassandra? I wanted to know the speed, like for the read. Like if we want uh, the strongest consistent means reading from all the nodes, all the replicas. What in general it is for Cassandra? It's fast, right?
No, that will be slow. If you are reading
No, no.
from
I
all the
mean
nodes,
slow, but at max, how much it will be in general? How many milliseconds for a per request?
I mean,
to be
you can't say that. I mean, it depends on the so many factors.
I think that should also depend on the cluster size, right? So or and the
Cluster size, number of replicas, network speed.
yeah, yeah,
Yeah,
correct.
yeah.
It could be like in like tens of millisecond to hundreds of millisecond. Like to be honest, like for a cluster size of 6, I have seen 100 to 200 millisecond of latency. If that might help you get some idea.
Yeah.
Shall we stop here? It's 7:30.
Yeah, yeah, yeah. Actually, yeah, we are already above time.
Okay, then see you all tomorrow.
Yeah. Thank you.
Thank
Yes.
you.
Thank you.
Bye.